If your coding agent only behaves correctly after you paste the same checklist at the start of every task, the problem is that your reusable procedures are being stored in the conversation instead of being packaged as part of the agent's working environment. In this video, I'm going to explain agent skills, what they are, how a coding agent discovers one when it loads the instructions, how a shared agents folder can fit into a multi-agent repo, and how skills are different from project instructions, /commands, tools, and MCP servers. Focus on the architecture. A skill gives the agent a small piece of always available metadata, usually a name and description. Then, only when the current request matches that description, the agent loads the actual instructions and any supporting files it needs. That separation is the key. Without it, teams often put everything into the global system prompt, code review rules, commit message style, deployment steps, migration checklists, design system rules, testing rules, release process, documentation format, and every other preference that has ever helped once. The more unrelated process you load into every task, the less room the agent has for the actual repository, the current request, and the files it needs to reason about. The skill system changes the flow. The user asks for something, the agent checks the available skill metadata, it compares the request against names and descriptions. If a skill is relevant, the agent loads the skill body. From there, it can read reference documents, use templates, run helper scripts, or call tools if the environment allows it. So the flow is request, skill metadata, trigger decision, skill instructions, optional resources, tool calls, result. That is the core model. A skill is a way to make task-specific procedure discoverable without forcing the full procedure into every conversation. A skill package is usually a folder with a required SKILL.md file and optional supporting files. The SKILL.md file contains metadata for discovery and instructions for the active workflow. The supporting files can hold reference docs, examples, scripts, templates, or assets that the agent only reads when the workflow needs them. Different harnesses can discover those packages from different places. Cloud Code Documents, ncloud/skills for project skills, and Azure/cloud/skills edge for personal skills. GitHub Copilot documents agent skills with SKILL.md and supporting resources in its own workflow. Codex uses the same broad package shape through its skills system and public skills catalog. The most important field is the description. That sounds small, but it is the trigger contract. If the description is vague, the agent may ignore the skill when it should use it or activate it for unrelated work. A description like helps with documents does not tell the agent enough. A better description says what the skill does and when it should be used, such as reviewing pull requests for a specific repository, generating release notes from merge commits, migrating a project from one API version to another, or creating a video timeline from narration regions. The description should contain the words a user would naturally write when they need that workflow. It should also be narrow enough that it does not match every nearby task. After the description triggers, the agent reads the skill body. That body should not become another giant prompt. It should give the agent the operating procedure, what to inspect first, what order to follow, what files matter, what tools are appropriate, what to avoid, and what the final output should look like. Longer material should move into supporting files. Reference docs, examples, templates, scripts, and assets can sit beside SKILL.md and be loaded only when the active task needs them. This is progressive loading, and it is one of the main reasons skills are useful for larger workflows. A code review skill might keep the main file short, read the diff, inspect related tests, prioritize correctness issues, cite files and lines, and avoid style-only noise unless it affects behavior. If the team has a long security checklist, that can live in a reference file. Be aware that skills are not project instructions. Skills are different because they are task-specific. A release note workflow should load when you ask for release notes. A migration workflow should load when you ask for that migration. A video production workflow should load when you are producing a video. Those procedures are valuable, but they should not occupy context during unrelated work. Slash commands solve a different problem. A command is explicit. The user types it because they already know which workflow they want. That is useful for named actions, but it relies on the user choosing the right command. The skill can be model invoked. The agent can recognize that the current task matches the skill and apply it without the user remembering a command name. Tools and MCP servers are another separate layer. A tool is capability. It can read a file, run a command, call an API, mutate a timeline, query a database, or fetch a resource. A skill is procedure. It tells the agent when a workflow applies and how to use the available context and tools to complete it. A good skill is usually created from a repeated failure or a repeated correction. If you keep telling the agent the same review format, that can become a code review skill. If every repo migration requires the same sequence of search, edit, test, and cleanup, that can become a migration skill. If a design system has rules that only matter when building UI, that can become a front-end skill instead of being loaded into every backend task. Skills should be reviewed like repo automation. Do not install random skills into a personal environment or commit shared skills without checking what they instruct the agent to do. Do not put secrets in skills. If the platform supports tool restrictions for a skill, use them when the workflow should be read-only or limited. The practical way to write a skill is to start with one narrow workflow. They sit between the user request and the agent's full working context, so recurrent task knowledge can load only when the task actually needs it. That's it.